Right now, somewhere in a Riyadh engineering office, a team is being asked to solve a problem that has never been solved before. Not just never been done here, never been done anywhere by anyone in the entire history of construction. They are trying to build a tower twice as tall as the Burj Khalifa, and here is the part nobody talks about. The Burj Khalifa already pushed engineering to its absolute limit. Wind pressure, foundation load, elevator mechanics, concrete pump pressure, every single one of those systems maxed out somewhere between floor 100 and floor 163. Rise Tower has 678 floors. So the question is not whether this building will be impressive, the question is whether the physics even allow it to exist. Let us start with the basics, because the numbers alone are genuinely hard to process. Rise Tower is planned to reach 2,000 meters, 2 full kilometers above the desert floor of Riyadh. For context, the Burj Khalifa stands at 828 meters, and it is currently the tallest structure humanity has ever built. Jeddah Tower, which the world spent years calling impossible, is pushing toward 1,000 meters right now on the Saudi coast. Rise Tower would be taller than both of them combined. 4.5 Empire State Buildings stacked on top of each other, more than a mile straight up into the air. At that height, you are not just building a tall building, you are building into a different atmosphere. The air pressure at the top of Rise Tower would be measurably thinner than at ground level. On a clear day, you would be looking down at clouds. This is not a skyscraper, it is something that does not have a name yet. The project is backed by Saudi Arabia's Public Investment Fund, the same sovereign wealth fund behind NEOM, the Red Sea project, and Jeddah Tower. Rise Tower is the centerpiece of a new urban development called the North Pole District, a 300 square kilometer master plan city in northern Riyadh, close to King Khalid International Airport. The design has been attributed to Foster & Partners, the London-based firm behind some of the most technically demanding buildings on the planet. Earlier competition renders also came from HKS Architects. A $1 million participation fee was charged to design firms entering the competition, which tells you something about how serious PIF is about the quality of proposals coming in. The budget estimated at $5 billion. For comparison, the Burj Khalifa cost around $1.5 billion, Jeddah Tower's budget sits around $1.2 billion. Rise Tower, at $5 billion, is not just taller, it is in an entirely different financial category. But here is the honest context, because this channel does not do hype without substance. As of right now, in March 2026, no construction has begun, no formal groundbreaking date has been announced, no contracts have been awarded. The project is not yet on PIF's official public list of giga-projects. What exists is a design competition, feasibility studies, and contractor bidding that opened in 2025. That matters, and we will come back to it. This is the section I want you to really pay attention to, because what Rise Tower would require from a structural engineering perspective goes far beyond anything previously attempted. At 2,000 meters, wind is not a nuisance. Wind is a structural force that has to be calculated, counteracted, and built around from the foundation up. The Burj Khalifa's famous Y-shaped floor plan exists specifically to disrupt wind vortexes, spiraling air patterns that cause a building to sway rhythmically and eventually resonate like a tuning fork. At 828 meters, engineers already needed a buttressed core, aerodynamic setbacks, and a spire designed specifically to break up those vortexes. At 2,000 meters, the wind forces are not just bigger, they behave differently. The building would need to be engineered so that wind hits it at different angles on different sections simultaneously, preventing the synchronized swaying that destroys tall structures. Rise Tower's proposed structural system uses a vertical cluster configuration, multiple interlinked legs supporting a central core, distributing the load across several paths simultaneously. The design also incorporates a triple helix structural core, intended to transfer wind forces around the building rather than absorbing them directly. This has not been tested at this scale. The Burj Khalifa used specially formulated concrete that had to be pumped to heights never attempted before, They could only pour concrete at night because the daytime heat in Dubai caused it to set too fast in the pipes. Rise Tower would need ultra-high-performance concrete with compressive strengths of 120 to 150 megapascals. For reference, standard construction concrete sits around 30 to 40. This material exists in laboratories. Deploying it at scale across hundreds of floors in Riyadh's desert heat is a logistics problem that has no established playbook. You cannot run a single elevator cable 2,000 meters. The cable alone would be too heavy to function. The Burj Khalifa solved this by using sky lobbies, intermediate transfer floors where passengers switch elevators. Rise Tower would need a far more complex version of this system. Multiple stages, sky lobbies at several height intervals, and ultra-fast double-cabin lifts capable of moving thousands of people per hour through hundreds of floors without creating bottlenecks. A malfunction in the vertical transport system of a 678-floor building is not an inconvenience, it is a survival scenario. Every elevator system, every sky lobby, every emergency stairwell would need to be engineered with redundancy built in at every level. Riyadh sits on desert soil. To anchor a structure that weighs what Rise Tower would weigh, the foundation would need to go deep enough and be wide enough to distribute that load without the structure slowly sinking or tilting over decades. Geotechnical surveys of the North Pole site are underway, but the engineering required here breaks ground in more ways than one. There is no precedent for a foundation carrying this kind of load in this type of terrain. Riyadh's temperature swings more than 40 degrees Celsius between day and night. Every material in this building, steel, glass, concrete, expands and contracts with that cycle every single day for the lifetime of the structure. At ground level, this is manageable. At 2,000 meters, multiplied across a structure of this scale, the cumulative stress on joints, facades, and structural connections is an engineering problem that requires materials and solutions not yet fully standardized in the construction industry. I want to give you my honest read here because I think you deserve the full picture. Saudi Arabia has a pattern, a real documented pattern of announcing projects at staggering scale, backing them with sovereign wealth fund money, and then actually building them slower than announced, sometimes redesigned, sometimes delayed, but building them. NEOM is being built. Jeddah Tower, which the world declared dead in 2018, is now at 85 floors and climbing. The kingdom has shown it will follow through on projects others call impossible. But Rise Tower sits in a different category, even for Saudi Arabia. At 2,000 meters, we are not talking about engineering at the edge of what is possible, we are talking about engineering that requires breakthroughs in materials, logistics, structural systems, and vertical transport that do not yet exist in deployable form. The project also faces a question that Jeddah Tower never had to answer. What is it for? Who fills 678 floors? The Burj Khalifa model, where surrounding real estate pays for the tower itself, worked at 163 floors in a city already flooded with tourists and capital. Whether it scales to 678 floors in a Riyadh district that is still being master planned is a financial question that even the most optimistic feasibility study cannot fully answer. Skeptics in the engineering community have pointed out that no prior building has come close to this altitude and that the risk of delays, redesigns, or abandonment is significant. That skepticism is not pessimism. It is just what the history of mega projects teaches you. But let us say it gets built. Let us say 2060 arrives and Rise Tower is standing. What does that actually mean? It means every engineering assumption we currently hold about how tall buildings can go gets rewritten. The structural systems, the materials science, the vertical transportation, all of it becomes a new baseline for what comes next. It means Riyadh becomes the answer to a question that Dubai used to own. What is the most ambitious city on earth? The Burj Khalifa did not just break a record, It repositioned Dubai in the global imagination as a place where the impossible becomes a postcard. Rise Tower, at twice that height, would do the same for Riyadh, at a time when Saudi Arabia is spending hundreds of billions to make exactly that repositioning happen. The tower would include luxury hotels, residential apartments, offices, observation decks, aerial parks, entertainment venues, and cultural spaces. It would be, in effect, a vertical city, a self-contained ecosystem at a height the atmosphere barely accommodates, and it would be visible from space. Here is where we are right now, in 2026. Jeddah Tower is climbing one floor every few days on the Red Sea coast. Rise Tower is still a competition render and a set of feasibility studies in northern Riyadh. But the bids are open, the architects are chosen, the money is there, and Saudi Arabia has proven more than once that when it decides to build something the world calls impossible, it tends to build it. Whether Rise Tower joins Jeddah Tower as proof of that, or becomes another chapter in the long history of projects that were too ambitious for the reality of physics and finance, that story is still being written. I will be watching it, and I will bring you every update as it happens. If you want the deep dive on Jeddah Tower, what is happening right now, what the real engineering risks are, and why the next few months are the most critical in the project's history, that video is linked right here. See you there!